Hi folks, we're going to take a look at numbers 21 and 22 on page 364 and their related questions. So here the scenario is that you've got a hockey player positioned 8 meters from the net, and they want to know what angle the player has to hit a shot into the net. Okay, and the two scenarios that we have is that the player is exactly in between the two posts. Okay, and in the second scenario, the player is in front of one of the end posts there. Okay, so you sort of think that while this is a hockey example, you can certainly think of it in terms of soccer also, sort of similar type of scenario. Now, of course, this is only considering sort of this horizontal thing. Also you have to think, the net has a height to it too. So this question is actually a little more complex, but we're taking sort of the simplified version of it. Okay, and they want to know which position would be better to have a better angle or at least size of angle to possibly score a goal into the net. Okay, so let's solve this left problem first, where the player is in front of the center of the net. So what we're looking for is this angle theta. Okay, but because you're right at the center or in front of the center of the net, we know that these two triangles are going to be the same. Now they tell us that the goal is 2 meters wide, so that means each of these sides is going to be 1 meter each. And so what we have is, since these two triangles are the same, I can just split up this angle theta into two smaller angles phi, which will be equal. So if I can find the angle phi, which is inside a right angle triangle, so that means we can use our trigonometric ratios, we can then just double that to find theta. Okay, this is actually an easier problem because since the and again 2 meters, because since they're just in front of one of the posts, we have just one right angle triangle to work with. Okay, so let's start with this one here. So I've got this side which is 8, and I've got this side which is 1. The 1 represents the opposite side to phi, and the 8 represents the adjacent side. So that's going to tell us which trig ratio to use. So we're don't care about the hypotenuse, and we have no information about the hypotenuse. So I'm going to use tangent. So tangent of phi is equal to the opposite side, which is 1, divided by the adjacent side, which is 8. And so now I have an equation I can solve. So in order to solve for phi, I have to use the opposite operation to taking the tangent, and the opposite operation is the inverse tangent, or tan negative 1. So we got to take tan negative 1 of 1 over 8, and that'll give us phi. So let's get our calculator here. Make sure it's in degrees, and it is. So inverse tangent of, now here the calculator I'm using automatically opens up a bracket here. If yours doesn't, you should be opening up a bracket before doing the 1 divided by 8, or else your calculator is going to do tan inverse of 1 and then take that answer and divide it by 8, which is not what you want. You want to take the tan inverse of this whole number, so make sure you use brackets. Okay, so here we have 7.125. Okay, so phi is equal to 7.125 approximately degrees. And so if I'm looking for angle theta, it's just 2 times phi. So 2 times 7.125. And what do we get here? Let's multiply that by 2, and we get 14.25. Okay. All right. So this is the angle that the player has to shoot the puck so that it goes towards the net. Doesn't necessarily mean it'll go in the net, because obviously you've got a goaltender in front here who can stop it. So now let's take a look at this second example. This one's actually a little easier because it's a one step. So again, we're going to use tangent because we know the opposite side, we know the adjacent side, so tangent's the one that's going to work. So tangent of theta in this case here is 2 over 8, and so theta is equal to, apply the inverse operation to both sides, so tan inverse of 2 over 8. And let's get that. So we've got tan inverse of 2 over 8 is equal to 14.036 degrees. Okay, so very close. And in fact, if we're going just to the degree, they would be the same, but this one here is a little larger. Okay, so that means that option 1 seems to give a slightly bigger opportunity to get the puck into the net. Okay, but then they ask you, what assumptions have you made? And at this point here, it depends, I suppose, how much you know about hockey. Is this somebody who hits from one side or the other? So if you're a right-handed shot, okay, if you know what that implies, this would probably be a better scenario, even though the angle is smaller. But because you're a right-handed shot, you tend to hit in that direction. So if you're here, you would tend to only hit in this direction here. Whereas if you're a left-handed shot, this would not be the right place to be. You might want to be on the other side. So there's all these other things that come into play when you're thinking about answering this question. But if you go solely by the angle available to the player, technically this one would seem a little better. Okay, now in the other part of 22, they ask you to repeat this process, and I'm not going to do it, but let's say, you got your 2-meter net here, and let's say you're 8 meters away, so this is in the second part. What's going to happen to the angle as you move closer or further away? And you see that as you move closer, you can actually calculate it, but in the diagram, you can see that you actually have a higher angle to work with. So not surprisingly, that the closer you are to the net, the more opportunity you have angle-wise to get it in. Whereas if you're further away, the angle gets smaller and smaller. Okay, and of course you can confirm that by picking something closer, say 4 meters to the post, or 12 meters to the post, and I think you'll see that what you'll get is a larger angle the closer you are, smaller angle the further you are, which I don't think should be too surprising. Okay, so again, just to recap here, main thing to realize was which trig ratio to use. In both of these circumstances, we had information about both the opposite and adjacent sides, so we used tangent, and then from there we just followed the algebra through. Okay, that's it for this one.